Hello everyone, I hope you guys are doing extremely well. Today we are going to discuss another problem in our binary search tree series. The problem name is Merge Two BSTs. So let us understand the problem description first. So we are given two binary search trees. That means we are given two root nodes of two binary search trees, and we want to print the elements of both the BSTs after merging them in sorted form. Okay, fine. So let's take an example to understand the problem description more clearly. So let us say we are given the root node of the binary search tree as node 3. The left child of node 3 is, let's say, node 1, and the right child of node 3 is, let's say, node 5. We are going to take a small example, and let us say the second binary search tree. For the second binary search tree, the root node is node 2. The left child of node 2 is, let's say, node 1, and the right child is nothing but node 4. Now once we have merged both of these two binary search trees, what will be the values? So the values will be nothing but 153, okay, 153 and then 142. Now printing all the values in sorted form is going to give me 1 1, then we have 2 3 4 5. So we want to print all the elements of both the BSTs in sorted form. So we want to print 1 1 2 3 4 5. Fine. So this is the output that we want. I hope the problem statement made sense to you guys. So let us understand how we can solve this problem. So let us take an example. Let us say the root node of the binary search tree given to us is nothing but node 55. The left child of node 55 is, let's say, node 45, and the right child is nothing but node 65. Now for node 45, the left child is null and the right child is null. For node 65, let us say the left child is 60 and the right child is nothing but node 70. This is the first binary search tree. Let us say the second binary search tree is node 33. For node 33, the left child is node 43 and the right child is nothing but node 53. Now for node 43, the left child is nothing but for node 33, the left child will be node 23 because it is a binary search tree. Now for node 23, let us say the left child is nothing but node 13 and the right child is nothing but node 30. Okay, for node 53, there is no left child and there is no right child. So what are the different approaches to solve this problem? Now, if you are sitting in a coding interview, the first approach that you should tell to the interviewer will be the brute force approach. Now, what is the brute force approach to solve this problem? The brute force approach to solve this problem is do an in-order traversal of these two arrays, of these two binary search trees. Now, what is the in-order traversal of the first binary search tree? It will be start from the root node, process the left. So we'll reach at node 45. Now for node 45, there is no left. So process 45. So 45 will be added. I have already made a video on in order, so you can check that out. So I'm just directly writing the in order. So the in order will be 45, then 55, and then 60, and then 65, and then 70, and that's it. So that in order will be 45, 55, 65, 60, 65, and 70. Now what will be the in order traversal for this? It will be start from 33, 23, 13. So first value will be 13, and then after it will be 23, 30, it will be 23, 30, and after this it will be 33 and it will be 53. Okay, now it will be 33 and it will be 53. Now once we are done with the in order traversal of the two binary search trees, what we can do, we can just iterate over these two arrays. So what we can do, we can just maintain two pointers. So first pointer will be present here, the second pointer will be present here. So now is 13 out of 13 and 45, which one is greater? So we can see 13 is greater. So we are going to add this value of 13 in some new array. Let's call it array as answer array. Okay, and now we are going to increase the pointer of this because we have added this value. So now it will reach to 23. Now for 23 and 45, which one is greater? So obviously which one is smaller? So 23 is smaller. So we are going to add this value and we are going to increment this pointer. So incrementing this pointer will lead us to 30. Now for 30 and 45, which one is smaller? So 30 is smaller. So what we are going to do, we are going to put this 30 in my answer array and we are going to increment this pointer. So incrementing this pointer, it will move to 33. Now out of 33 and 45, which one is smaller? So 33 is smaller. So we are going to put this 33 in my answer array and we are going to increment our pointer. So our pointer will point to node 53 now. For node 53 and node 45, which one is smaller? So node 45 is smaller. So we are going to put 45 in my answer array and we are going to increment this pointer now. Okay, so now our pointer will point at node 55. Now for 55 and 53, which one is smaller? 53 is smaller, so we are going to put 53 here and we are going to increment the pointer. So now when we will increment this pointer, that means it is going out of the bound. There are no value left to compare. So what we are going to do, the values that are left in either of the array, we are just going to put that value, those values in the answer. So these all values will be put in the same order. So 55 will be put, then after this the pointer will be increased, it will point to 60. Now 60 will be put. After this the pointer will be increased, it is gonna point to 65. Okay, now 65 will be put. After this the pointer will be increased and it is gonna point to 70, so 70 will be put. And after this the pointer is gonna point to the next, and there is no next value, and that's it. And as you can clearly see, we are getting the output of the nodes in the form of an increasing array. As you can clearly see, 13, 23, 30, 33. So yeah, this is a sorted array, and we have printed all the values of this node in sorted form. Now talking about the time complexity of this approach, we have done an in-order traversal of both of these two binary search trees. So the time complexity is nothing but big O of n1 for this in-order traversal of first binary search tree. If there are n1 nodes, big O of n2 if there are n2 nodes present in the second binary search tree, and after that we are just doing two pointers approach, so that will be nothing but big O of n1 plus n2. So the overall time complexity is big O of n1 plus n2 plus big O of n1 plus big O of n2, which we can write it as big O of max of n1 comma n2, that is whatever the maximum number of nodes present in any of the binary search trees, that will be our time complexity. And talking about the space complexity, the space complexity is we are creating two extra arrays, so the space complexity is nothing but big O of n1 plus n2. Okay, fine. Now is this solution good? Yes, this solution is really good. It is linear, but is there a better solution? Yes, there is a better solution. Now what is the better solution? The better solution is, rather than generating all the numbers in order traversal in the beginning, we can keep generating while we are traversing the in-order traversal. So how can we do that? We just need to do an in-order traversal without recursion. Now how can we do an in-order traversal without recursion? I have already explained you. I have already made a video on that. So what you need to do, whenever you are going to get a node out of that stack, you need to compare the value from stack 1, that is for the first binary search tree, and then from the second binary search tree there will be a stack 2. So you need to compare both the two values. Now whatever the value will be smaller, you are gonna push that value in my answer, and after that you are going to process the right subtree of that node. Now if this is smaller, so you're going to process this nodes. If this is smaller, you are going to process this node. So this is how we can solve this problem without creating these two extra arrays. But I'm not gonna write the code for that, because I'm just giving that as to you guys so that you guys can give it a try as well, because I've already explained you the code for without recursion of in-order traversal. So please try it by yourself. Now I'm going to write the code for this approach, that is once we have these two in-order traversals. So I'm going to write the approach for this. So let us understand how we can write the approach for this. Okay, so as we can clearly see, I have already declared a function called Merge BST, that is taking the root node. The root 1 is representing the root node of the first binary search tree, and root 2 is representing the root node of the second binary search tree. These two are nothing but the objects of class tree node. Tree node is having a constructor that is initializing the value of the node. The left and the right child of any node is by default set as null. Now what we are going to do, we are going to do the in-order traversal of both of these two nodes, and we are going to store their results in some array. So arr1 is equal to do the in-order traversal of root 1, that is the first binary search tree, and after that do the in-order traversal of the second binary search tree. So how can I do an in-order traversal? So I've already explained you. The in-order traversal is nothing but firstly process the left subtree, and then process the node, and then process the right subtree. So I've already made a video, please check it out. So first of all, we need to do that if my current node is null. In that case, we just need to return. Now after return, what we are returning, we are going to return an empty list. Why we are returning an empty list? Because we want the values stored in the form of an array. So we are returning an empty array here. Okay, now after this we need to process the left call. So left answer will be nothing but in order traversal root.left. Now after this I just need to process the current node. So how can we process the current node? I just need to make current answer as root.value. That means I need to add this root.value in the form of a list. Now after this I need to process the right subtree. So how can I do that? Right answer will be nothing but call the in order traversal, and then it will be root dot right. Okay, so it will be root dot right, and after this I just need to return. So what I need to return? I need to return left answer. That means firstly we have processed the left node, left subtree. After that we have processed the node. So how can we return the node? We need to return current answer, and after that we need to return the right answer. So return left answer plus current answer plus right answer. Don't forget the order, because ordering is important. In order traversal we process the left answer, then we process the current answer, and then we process the right answer. So we have merged them in this order. Now once we are done with this, that means we have got the in order traversal of both the two binary search trees, and those twos are stored in ARR1 and ARR2. Now after this we need to find the length of these two arrays. So how can I do that? I just need to say m is equal to length of ARR1 and n is equal to length of ARR2. Now I need to initialize two pointers. Initially both the two pointers will be present at the 0th index. So let's say I is equal to j is equal to 0. I need to initialize an answer as well, which is going to print all the values in the sorted order. So answer is equal to initially empty. Now while I is less than m, that means we have not iterated the first array, and j is less than n, that means and we have not iterated the second array. So now we are going to compare these two values present at these indices. So if ARR of 1 of I is smaller than ARR of 2 of j, in that case we are going to add this value. So answer dot append ARR 1 of I, and in that case I need to increment I plus equal to 1. We are incrementing the I pointer. In the second part, in the else part, I need to do answer dot append ARR 2 of j, and in that I need to increment by j. Okay, fine. Now after this, maybe one of the array get exhausted. So as we have seen in the example, the second array got exhausted. So what we need to do? We need to add all the values of any array that is left in my answer. So how can I do that? While I is less than m, I just need to keep adding values. So answer dot append ARR 1 of I and keep incrementing I plus equal to 1. Or we can have j while j is less than n, that means there are some values present in the second array. So in that case, while j is less than n, answer dot append ARR2 of j, and after this j plus equal to 1, and that's it. That's all we needed to do. After this I just need to return answer, and answer is going to give me the values in the sorted manner. So that's all about the code. So what we have done, we have just done an in order traversal of both the two binary search trees. Once we have done the in order traversal, we have used the two pointers approach to solve this problem. We have initialized two pointers I and j as 0, and now we have compared every value for every node. For every value, if it is greater, we have incremented the pointer. Okay, and if the second array is greater, that means we have incremented the first pointer. If the second array's value is smaller, that means we have incremented the second pointer. Okay, fine. Once if there are some values left in both the two arrays, we have added the values. Fine. And in the end I just need return that answer. So let's just declare two root nodes to check our. So root 1 is nothing but tree node 15. Let's say the left child is nothing but, I'm gonna take a small example to run my code. So root dot left, that means the left child of node 15 is nothing but node 5, and the right child is nothing but node, let's say 20. Okay, now this will be root 1 dot left. Okay, root 1 dot right, and now let's make the root 2 as nothing but tree node 12. Now the left child of root 2, that is left child of node 12, is nothing but, let's say, node 2, and the right child is 25. Okay, fine. Now I'm taking a small example to run my code. So let's pass these two nodes in my merge BST function. So merge BSTs and pass root 1 and root 2, also print the output. So how can I print the output? I can just put a print here. So print merge BSTs, and that's it. And let's just give this function a run, and let's check the output of our code. So the output of the code is coming out to be 2, 5, 12, 15, 20 and 25, and as you can clearly see, all the values are present in this sorted order. That means we have printed the values of both the two binary search trees in the sorted manner, and that is why we can say our output is totally correct. I hope the code made sense to you guys. I want you guys to practice the second approach, which I have told you, that using in order traversal without recursion. In that case, we don't need to construct these two arrays. We can just keep traversing while we are putting the values onto the stack. So I want you guys to please practice that approach by yourself. If you guys still have any queries regarding this problem, please drop your concern in the comment section and I will be more than happy to help you there. Regarding this series, I will be uploading more of the questions in the upcoming week, so keep following us. Until then, keep smiling and keep coding. Thank you.